we are going to graph these very similar to how we did sine and cosine. So the table that I have for cosecant, I put the 0, pi over 2, pi, 3 pi over 2, and 2 pi, just like we did with sine and cosine. We know cosecant is the reciprocal of sine. So sine of 0 is 0. Cosine of pi over 2, or sorry, sine of pi over 2, not cosine. Hold on, let me back up. I said cosecant, but I didn't do the reciprocal, did I? Sine of 0 is 0, so cosecant would be undefined. Okay, at pi over 2, sine of pi over 2 is 1. So cosecant, the reciprocal of 1 is 1. Now for the others, if you need to, you can go back to your unit circle picture that we looked at. At pi, the point is negative 1, 0. We know sine is the y. So sine is 0. So cosecant would be undefined. At 3 pi over 2, sine is negative 1. So cosecant would be negative 1. 2 pi is back to 0, so it's back to undefined. Then if we look at this, everywhere it's undefined, we have an asymptote. At pi over 2, it was 1, and at 3 pi over 2, it was negative 1. Now really, I don't have enough points here to necessarily know what the graph looks like. We could pick more points, but what I want to do instead is take a second and graph sine. If you're graphing this on your paper, do it very lightly. Sine of 0 is 0. Pi over 2, sine is 1. Back to 0, negative 1, 0. This is what the graph of sine looks like. Cosecant is just the reciprocal of that. So every time it was 0, we get an asymptote. These high and low points stay. And then what happens when you do the reciprocal, it actually just takes your graph and reflects it away from the x-axis. So it's going to look like this. So it's these parabolas. And they would continue, if you wanted to draw more, it's just going to continue the pattern. You're just going to alternate upward and downward facing parabolas. That's all that's going on. So for the domain of this, what can x not equal? Where do we have asymptotes? 0, pi, 2 pi, and so on. My range, what y values do we hit?
Except for what's on that original.
It's kind of the opposite of sine. Sine hits everything between negative 1 and 1. Cosecant does the opposite. It hits everything from negative infinity until negative 1. Union everything from positive 1 to infinity. Is this graph even or odd? Is it symmetric to the y-axis or the origin? Origin. So this is another odd function, which just like for sine, tangent, and cotangent, those are all odd. What that means is if you have cosecant of a negative, the negative just comes out. Questions on that? Let's do secant. secant is the reciprocal of cosine. Cosine of 0 is 1, so secant would be 1. At pi over 2, cosine is 0, so secant would be undefined. At pi, cosine is -1, so secant is -1. 3 pi over 2, cosine is 0, so secant undefined. And at 2 pi, you would be back to 1. If we graphed cosine starts at 1, and it goes 0, -1, 0, and 1. Cosine looks like this. So everywhere that graph was 0, we had an asymptote. The high and low points are staying, and then our graph is just going to reflect. This will go up. Let's go down. So the green line really isn't part of my graph. The purple is the actual graph of secant here. Our strategy for these graphs, probably the easiest option, is to start out graphing the sine or cosine. We know how to graph those, we've done a lot of them, and then just get your secant or cosecant from that original graph. That way you're not trying to remember a pattern or anything like that. The domain. What can x not equal on this one? Pi over 2, 3 pi over 2, what would the next one be? 5 pi over 2, and so on. The range would be? Is this one even or odd? Even. If you finish this off, you just get the other half of that parabola here. If you flip this graph over the y-axis, it overlaps itself. So this is even, which means if you have secant of a negative angle, you can just drop the negative. What was our one other even function? Cosine. Cosine and its reciprocal, secant, are even. The other 4 are odd, so you would have to pull the negative out. So let's just go to our notebooks then and try graphing a couple. To start out just like we were doing a sine or a cosine. So we're going to go through that list of information. What is the amplitude? 2. Period. For tangent and cotangent, normal period was pi. But for the other 4, it's 2 pi. So it'll be 2 pi divided by 1/2. Gives me 4 pi. Count by, period divided by 4, and we get pi. Would I have to do an interval on this one? No. You could if you wanted. If you have something added or subtracted to your x, you absolutely have to. Otherwise, it's optional. So I could just jump in with my graph now. So start at 0. Here we have pi, 2 pi, 3 pi, and 4 pi for our points. What I'm going to do, secant is the reciprocal of what? Cosine. So I'm going to start by drawing my cosine graph. Now, here's what I need you to do. If you draw your sine or cosine first, I have to be able to tell the difference between that and what your final graph is. So either very lightly draw it in, or I have some people that once they graph the secant or cosecant, they like to highlight it, or some people go back and erase their sine or cosine, but something so I can tell that is not part of your final answer. So my cosine graph would start at its amplitude, which is 2, and it would hit 0, -2, 0, and back to 2. So this is what cosine looks like, just lightly sketching that in. Then, anywhere this was 0, we can put an asymptote. These high and low points stay. Then you just reflect your graph away from the x-axis. So keep in mind, you need to draw it approaching your vertical asymptote, so this is just going to be going up, getting closer. Here's got a little parabola. And this side looks like that. So that purple part there is my actual secant graph. I just used the cosine to help me see where my asymptotes would go. Any questions on that? Amplitude. There you have. What's this 1 do? Okay, period. Normal period for secant and cosecant is 2 pi divided by the coefficient of x, which is just a 1, so period is 2 pi. Count by period divided by 4, pi over 2. What else do I need? I know. So you set it between 0 and 2 pi, add your pi over 2 to everything, so pi over 2 is less than or equal to x, is less than or equal to 5 pi over 2. So we start at pi over 2 and add pi over 2 each time, so that would be pi, 3 pi over 2, 2 pi, and 5 pi over 2. Would you start out graphing sine or cosine on this? sine. It was cosecant, so reciprocal of sine. Sine starts at its 0 point, but what else have we done on this graph? We're moving f1, so I need to go to positive 1 and draw in my axis. So sine at pi over 2 would be on the axis. Then it goes up 3/2, so up to 2.5, back down the axis, down to negative 1/2, back up. So there's my sine. So for cosecant, every time that's 0, I'm putting a vertical asymptote. High and low points stay. And then we need to reflect our graph away. So it should look like that. And of course, if I ask for a second period, you would just keep doing the same thing. Add 4 more points and keep going. How do you guys feel about these? Good. Do I need more drawing the graph problems? I would like to do just 2 examples of writing an equation for the graph. We did that with sine and cosine. We skipped that part with tangent and cotangent, but I want to go ahead and do it again today. We'll try a couple of those and then I'll give you time to work on your homework. If I were to graph this, right here I have a vertical asymptote. That means my sine or cosine is 0. That point would say it was back to 0, back down, looks like this. So is this one that I'm drawing, sine or cosine? Sine. So that means the original graph has to be a graph of cosecant. Okay, amplitude. How far above and below the center do we go? Just 1. So I don't need anything in front. Was it flipped or anything? Moved up or down? Okay. Period is, how long did it take before this graph repeated? 4 pi. Okay, we find period by doing 2 pi divided by the number in front of x. So if I multiply over my b, divide by 4 pi, I get 1. So it's y equals the cosecant of 1/2 x. For b. There's a little more going on here. I could start by drawing my sine or cosine, but what else has happened on this graph? It moved up. So this graph is actually centered here at 1. So then am I drawing in a sine or a cosine? Sine. So that means this is the graph of cosecant. And it did move up 1, so you need a +1 either at the beginning or end. Amplitude. How far above and below that point do we go? 1. Did I flip it? No, so I don't need anything in front of my cosecant. What we do have going on, though, is when I go to look at my period, this graph didn't start at 0. So the period is a little more complicated. If your graph doesn't start at 0, probably the easiest option is to work backwards from the interval. You know, when we move left or right, we set up an interval. So if our graph has been moved left or right, let's look at that interval. This graph started at negative pi over 2 and ended at 3 pi over 2. A normal one would start at 0 and end at 2 pi. So I am going to work backwards from this to get back to 0 to 2 pi. So if I want this to be a 0, what would we do to everything? Add pi over 2. X plus pi over 2. 3 pi over 2 plus pi over 2 is 2 pi. So is that what we wanted? Yeah. So this is just the cosecant of x plus pi over 2. With a plus 1, you could also have 1 plus cosecant of x plus pi over 2. Do we need more of this? You guys just want to try your homework and ask me for help when you need it? Nobody wants homework for the weekend, right?